Alright, welcome back to a little bit of pre-algebra. We are in chapter 5, section 2, and we're looking at the Pythagorean Theorem. Okay, so there's this dude. His name's Pythagoras, and he was a Greek mathematician and philosopher. He discovered one of the most well-known rules in math, and in math, a rule is also called a theorem. All right, and so that gives us, from this guy's name, Pythagoras, and finding a rule, which we call a theorem, the Pythagorean Theorem. That's a lot of fun to say. You should practice saying that right now. Pythagorean Theorem. All right, and this is something that most of you guys have probably already heard before. You're familiar with what it is, but let's look at how to use it. So the Pythagorean Theorem is a squared plus b squared equals c squared. Okay, well, but what does that mean? Okay, what's a squared plus b squared equals c squared? All right, so it's talking about a right triangle. Okay, so a right triangle where we have a right angle, and in a right triangle, we have two sides that are called legs. All right, so the legs, there we go. The legs are the short sides. They are the sides that are adjacent to the right angle. And then the long side is called the hypotenuse. Hypotenuse is the side opposite the right angle. Now that side is labeled as C. Big and bold in your notes, write for yourself here. C is the longest side. All right? C is the longest side. Write that down. That is what you have to remember, because sometimes we are looking for C. We're looking for the longest side. A squared plus b squared equals c squared. C is the longest side. It's very important that, all right, that we remember, whoop, boom, there, see? Oh, that's fancy. That this longest side is C. A and B are kind of interchangeable because it's plus, right? So it doesn't matter which one we call A or B. Those are the two short sides. But C is very important that we remember that is the longest side. All right, so let's look at an example here. Let's see. This example right here. We've got a triangle where this side is 3, this side is 4, and this side is 5. Okay, so if we have a squared plus b squared equals c squared, well, look at this fancy diagram right here. Okay, we have that triangle, 3, right here, 3, 4, and then this side is 5. Well, let's see, 3 squared, a squared plus b squared equals c squared, right? That's what the Pythagorean theorem is. Ooh, look, that arrow's still there. Boom, gone. All right, a squared plus b squared equals c squared. So we take a squared, that gives us 9. B squared is 16, right? 3 squared is 9. 4 squared is 16. Okay, let's put the squares next to that. That's 9. That's 16. 9 plus 16, add these two together, and we get 25. That is 5 squared. So if I take this, and this is an illustration of the square, right? 3 by 3, 4 by 4. Okay, and that's how we get this. Now, if I want to find what the length of this is, then I would have to take this last number and square root it, right? Because if you just add them together, you get the square of c. You get c squared. C squared is 25. So if I want to find what c is, I have to square root it. Different color, how about that? Boom. Square root it. And then c is equal to square root of 25 is 5. There we go, we found it. Okay, let's look at a couple examples. Find the missing length. Okay, we're going to find the missing length here. This time we are looking for c. Okay, so we want to find c. We know a and b. All right, so a squared plus b squared equals c squared. And forgive my writing here, I'm writing with a mouse. So a and B are the legs adjacent to the right angle, so that's 5 squared plus 12 squared is equal to C squared. 5 squared is 25, plus 12 squared is 144, and that equals C squared. Well, 25 plus 144 is 169, and that is C squared. Now notice that this length is not 169 meters. It can't be, right? That's not even possible. If I put these two lengths back to back, 5 and 12, the longest possible that would be 17, and that wouldn't even be a triangle anymore. That'd just be a straight line if I put these back to back. So this has to be shorter than 17. What do we still need to do? Oh, right. We need to find the square root, right? And then square root it. There's nothing to it to find the measure of the longest side. C is 13, and that makes sense. That is longer than this side, but shorter than these two combined. All right, very nice. Let's look at another example. Okay, so right here. Now notice in this one, we know C. This side here is C. The first thing you should always do is determine where is the C. Okay, we know C. We don't know A. All right, so if I write A squared plus B squared equals C squared, well, I don't know A, but I know B and C, so I can plug those in. A squared plus 2.1 squared is equal to 2.9 squared. Well, it's not very pretty, but it'll work. All right, let's square these. 2.1 squared is 4.41, and 2.9 squared is 8.41. Okay, now to solve this, we are going to do a little subtraction action here. Minus 4.41 and minus 4.41. All right, and that gives us a grand total of, this cancels out, A squared is equal to 4, and this one's easy. We're going to square root that, always our last step, and then square root it. There's nothing to it. A is equal to 2, and that makes sense because that is shorter than C, and combined C is shorter than these two combined. Very nice. All right, so that's our little intro to the Pythagorean Theorem. All right, there we go. Lots of fun. Check back again next time for another fun lesson in pre-algebra.